Yes, would you ask Mr. Partlow to come back in, please? Right, Mr. Partlow, are you ready to carry on?
Yes.
Good, thank you very much. Yes, Ms. Grange.
Yes, thank you. Yes, so we were midway talking about the tests on the door opening force. If we could go now to email PSB 401140 and look at page 1. So just looking at the email at the top of the page from David Harrison to you on the 13th of May 2016, he says, I know you've got this mail, but someone more knowledgeable than me needs to say how we can do this and what kit we need to satisfy the Building Control Officer, BCO. Also purchase a calibrated spring gauge in newtons. Do you see that there?
I do, yes.
Does this show that PSB didn't have such a gauge themselves at the time?
They had a gauge. It wasn't calibrated and it were in kilograms.
I see.
So we had to convert kg to newtons.
Right.
So 10 kgs is 100 newtons.
I see. Does that mean that it wasn't normally part of PSB's commissioning process to test these door opening forces?
No, we tested them. But the gauge that we had, we needed to get one that was actually measuring newtons, because then it had been 0 to 100 or 0 to 200. And we did get them, and whereas the one that we had, you had to physically look at it while you were doing it. This one had like a little memory on it, so that whatever the maximum force registered was, that's what you saw. Yeah,
but given that all the key pieces of guidance seem to suggest that it's 100 newtons that you're going, that newtons is the unit by which you're measuring it, isn't that surprising that PSV didn't have that piece of kit already?
Well, it was in kg, and 10 kgs is 100 newtons.
Right.
It's only a case of if you get 9.7, it's 97.
I see. So you thought you needed to get on this job?
Well, because the letter from Alan White, I think it was, said that they needed to do the readings in newtons. If we were called back to take them again, then we should have a gauge that was in newtons, basically.
I see. And then if we can go to PSB 401141 and look at this email. So this is from Alan White to you on the 13th of May 2016. If we can just blow up the email a little bit. So he says, morning Alan, just as a preamble, the smoke control system has been designed to provide the existing stairwell with protection from the ingress of smoke from a fire within a dwelling by means of a mechanical extract system. System designed for an open door velocity, that's the second paragraph. Third paragraph, the control system will also, I think that should be have, pressure sensors added to each ventilated lobby to control the speed of the fans to ensure that when the doors on the escape routes are closed, the opening force on the door does not exceed 100 newtons as detailed in that standard. To this end, the system supplied and commissioned complies with the standards and has been accepted by all consultants building control over time. We are not entirely clear or understand what additional information you wish to achieve above what's been carried out to date. It would be greatly appreciated if you could send the additional requirements. So that's what that's what David Harrison is saying to Alan White, copying you in at that stage. And then if we could go to an email of the 27th of May 2016, this is at RYD 3079494. This is an email of the 27th of May 2016 from Jonathan Earl of JS Wright to Steve Blake at Ryden, with a progress update. And if we look at point 1, you're not one of those CC'd into this email. At point 1, it says PSB actions plus O&Ms. O&M have been issued for comments. In regards to the pull tests, these have been witnessed to 85 newtons and the test results are identified in the attached email. PSB have stated the information given is the requirement to commission this type of system, but if further pull tests and volumetric evidence is to be witnessed, please advise a date. They are more than happy to discuss with building control. Do you know, and can you help us, whether any further door tests were carried out after this time?
Not to the best of my knowledge.
No. Okay. Now, the fifth acceptance test is called activation of the system. If we go back to the British Standard at RBK 3045054, page 73, we can see at 2.2.5, in the second half of that page, activation of the system, and it says the last test shall be to operate the automatic fire detection system smoke detector by injecting smoke into the detector head. This shall in turn operate the central fire alarm panel, thus activating the pressure differential system. Now, if you go to paragraph 80 of your first statement, that's on page 14, you tell us there that the detector was activating using a can of artificial smoke to spray the smoke head. This is the only way to activate the system when it is set to run. Now, is that right, that how the test was carried out? So would one of you be at the HMI panel and the other be setting off the detectors with an artificial can of smoke? Is that correct?
Yeah, the reason why one would be at the panel and one at the detector is because once you've activated the detector, to reset the system, that can only be done at the HMI panel.
I see.
So it would depend what part of the testing we were doing. So if for example, I was looking at, was the HMI recording the same information that was actually happening on the fire level? So I'd be looking, if Gary sprayed it and it were on level 21, I'd be looking to see if it came up fire detected level 21.
Yes.
And then in the page it'd say dampers, SDO, whatever, open. They'd have to match up with the ones that were on floor 21.
Yes. Yes.
And if you were doing multiple floors, there'd always have to be somebody at the HMI, because to move to another floor and test another detector, you've got to reset the one that you've just activated.
Yes, I understand. Yes. Then, so in terms of these final commissioning steps, in paragraphs 93 to 100 of your first statement, I don't think we need to pull them up, and you explained that as the final commissioning step, you checked that the system worked as intended in the cause and effect document. Is that right?
Yes.
And we're going to go into each check that you did at this final stage in a moment, but did that involve activating the system on each floor?
Yes.
Checking that all the smoke detectors operated correctly?
Yes.
Checking that all the dampers were opening and closing correctly on the correct levels?
Yes.
i.e. opening on the fire floor and closing on all the other levels, that was checked, was it?
They should all be closed, but if you were doing it from environmental mode to fire, for argument's sake, then you would have to check that all the other dampers are closed, which we did do, and we did that check during one of the demonstrations.
Right.
Because we activated environmental mode, then activated a smoke detector.
Yeah, we'll come back to that in a moment. And then, did you check that the override facility on the HMI panel and the fireman's override switches all operated correctly?
Yes.
Yeah. Now, going back to the list that we saw in the Smoke Control Association guide, this is at RBK 402932 at page 59. We can see that the first check is operate each motorised damper by activation of the designated manual or automatic device. Now, we know that in total at Grenfell Tower there are 92 dampers plus 2 separate automatic opening vents which need to be commissioned. Do you recall that it was, of that magnitude, the number of dampers that had to be checked?
Possibly, yes. Well, definitely.
Now, if we look at the PSB commissioning report, this is at PSB 50224, page 3. The second table records, on this page, records the dampers, door actuators, window actuators. And we can see that the dampers are there at they're SD01 to SD48. Those were some of the dampers, yes?
They were all of them.
But then there's also CD01 and CD02 dampers.
Yes.
Do you see those as well?
Yes.
Now, in your first witness statement, you've explained that the SD numbers relate to the dampers. So SD09 was the first damper on floor 4, and SD48 was the last damper on floor 23. Is that correct?
Yes, if that's what it was.
Or should that be SD01 was the first damper on floor 4?
No, SD01 were on ground level.
Right. And then you've told us that the reference to CD01 and CD02 here relate to the shut-off dampers, which enabled the system to switch from environmental mode to smoke control mode. Is that correct?
Yes, that's correct.
So they're at level 2, yes?
Yes.
And you've said that the dampers were numbered in the same way on the cause and effect spreadsheet, yes?
Yes, and on the 800 drawing.
Yes, and is it right that the dampers were wired together in pairs, explaining why this number is less than the full 92 dampers?
On the smoke dampers, yes, because what you'd got, SDO1, which I'm assuming from memory was the south shaft smoke damper on ground level. Well, on ground level it was one damper, but from 4 to 23,
Yes,
there was two dampers into the same shaft.
yes,
So if it were 9, SDO9
yeah,
would have been the two dampers in the south shaft.
yes, I understand.
SD10 would have been the two dampers into the north shaft.
Yeah. Now, if we can go to a figure of Dr. Lane's Phase 2 report, this is BLARP 2, 5035 at page 96. So we want figure 4.15, if we could blow that up. So this is a diagram that we've got from Dr. Lane, which shows where the 4 dampers were at level 2. We can see 1 is the environmental inlet bypass damper, 2 is the smoke outlet bypass damper, 3 is the smoke inlet bypass damper, and 4 is the environmental outlet bypass damper. So basically in environmental mode, the air would go around the blue ducting, wouldn't it, with those dampers open, yes? But then in smoke control mode, those 2 dampers at 1 and 4 would have to shut, yes? And the dampers at 2 and 3 would have to open, is that correct?
Yes.
Yeah. Now, can you help us as to which of these dampers, there are 4 down there, are CD01 and CD02, because we currently don't know that.
The 4 dampers were on the sketches that were put in. They were installed, but they were never, only 2 were used, CD01, CD02. You only need to isolate the environmental air and the smoke side with a damper on each side of it. You don't need 4 dampers. So CDO1 is the smoke damper, CDO2 is the environmental.
Right, so when you say CDO1 is the smoke damper, where on this drawing do we see the smoke damper?
Well, I'm not quite sure, but I think it's the one next to the shaft.
Can
and
you-
the same applies to the other
You've got
one.
4 little circles with numbers in on this drawing. Can you tell us where CDO1 was, the smoke damper?
It would have been at one end or the other of the red shaded ductwork.
Right.
There weren't 4 dampers in there. There were 4, but 2 weren't in use. They weren't connected. They were
Which
just held open.
Which were the 2 that were held open?
Well, it would have been 3 and 4 if there were 4 in. CDO 1 and 2 were the only
I
2
see.
in use.
So what you're saying is at points 3 and 4, they were permanently held open, yes? So are you saying that in environmental mode, number 1 would be open
Yeah.
and 2 would be closed?
Yeah,
And in smoke control mode, 2 would be open and 1 would be closed?
yeah.
And CDO 1, therefore, if you're saying that's the smoke control damper, are you saying that's number 2 on this drawing?
Well, if that's the case, yes.
Right, and CDO 2 would be number 1 on this drawing? Yes? Yes, I see. If you go to PSB 50232, this is the cause and effect chart. In paragraph 144 of your first statement, you mentioned this spreadsheet, but and we've looked at it before, but it's right, isn't it, that this chart doesn't show the CD01 and CD02 dampers on it?
No.
Why was that?
Well, I didn't draw the cause and effect chart up, but it was probably deemed that it's only the fire zones and fire dampers that needed to be on there. Obviously, in the mechanical spec and the drawings that I worked to, they were shown as CDO1 and CDO2.
But you see, again, someone picking up this documentation and using it subsequently, how would they know from this chart that there were actually quite important dampers down at level 2 that needed to operate correctly if the system was going to switch over from environmental into smoke control mode? How would they know that?
Because they're in the control panel wiring drawings.
So you'd have to look at those drawings to work that out.
Whenever you're working on anything, you've got to look at more than one document. You've got to look at least, sometimes up to 4 or 5 different drawings and documents.
Yes, but why doesn't this cause and effect chart get amended to add in those 2 dampers?
I've no idea.
Can we agree they're pretty important dampers, aren't they?
Well, they are important, definitely.
Yeah. Now, if we go to paragraph 81 of your first statement at page 14, you tell us at paragraph 81 about how you did the checks on the dampers. Gary Doyle checked to make sure that the dampers on that level opened by checking that the red light on the smoke detector was lit and that the LED near the output on the relevant Modbus outstation card was lit, which showed that the correct signals were being sent and received and the dampers were activated. Gary Doyle also carried out a visual check that the dampers were working. I also asked him to open and close the door to the stair to check that the fan speed increased when the door was open. I was positioned at the HMI panel. I checked that the HMI panel displayed a message stating that the fans were running and on, which level smoke had been detected. Now, if we go to a photograph now, BLARP 2 5035 at page 194. This is an image from Dr. Lane's Phase 2 smoke report. On the screen, we can see a post-fire photograph of these are the south dampers on level 4. And that you can see one has got the grill still on the right-hand side and the other with the grill removed. Did either you or Mr. Doyle check the dampers with the grills in front of the dampers removed?
No, we checked them with the grills in position. All that had been bolted back up.
Yeah.
All those grills were held on with anti-tamper screws so that residents couldn't take them off, basically.
So you couldn't have taken those off when you
but-
were checking
but
the dampers?
We can shine a torch through it and see whether it's open or closed.
So when you say Mr. Doyle carried out a visual check, that would mean looking through the grill
Yes.
at the damper, is that
Yes.
correct?
Yes, and if the damper's closed, it would appear like the picture on the left-hand side. If the damper's open, the blades would have been horizontal, and you'd be
Yes.
able to see into the shaft.
Yes, I see. Now, if we look at paragraph 42 of your first statement on page 8, at paragraph 42, when you're dealing with the dampers, this is what you said in your first statement. Grills were fastened onto the front of the shafts where the dampers were located, so it was not possible to see the dampers and actuators, the motors that drove the dampers, that clearly. So that's what you're saying there.
Yeah, you could see whether or not the damper had actuated open and actuated closed, but you couldn't. You had to use a torch and shine it through a light, like reading a meter in a meter cupboard.
I see.
You
Yeah. And that's just the way it was it? I mean, is that always the case in commissioning, that with something like this you're looking through grills?
No, because in normal commissioning on a building, we wouldn't be looking through grills. All the grills would be removed
Yes.
at the initial stages of commissioning. Once we'd checked all the dampers were functioning correctly, not sticking, no problems, the grills would have then been put on by the installers.
Yes. So why didn't that happen here? Why?
The grills were already on. We didn't take the grills off, didn't install the dampers, and when we actually got to site on levels 4 to 23, all these, with the exception of one, all these dampers and grills were all the dampers were wired up,
Yeah.
and all the grills were in position, and as I said, the grills were held on with anti-tamper screws.
Yes. Did you ever raise the lack of clear sight of the dampers with anybody? Did you ever raise that as a concern?
No, because I could see whether the damper was open or closed. It wasn't a case of, I can't see it, so I don't know if it's open or closed.
Yes.
All I'm saying is the view was partially obscured, but not to the level that you couldn't see if it had actuated.
Yeah. I just want to ask you about what other checks you performed on these dampers. Did you ever test the wiring of the dampers behind the grill?
From the outstation, yes.
When you say from the outstation, what does that mean?
Well, I did dead testing on the damper cabling to make sure there were no short circuiting, and then tested for the continuity through the damper motor, and then obviously when you power it up and drive it closed, it's obviously working.
I see. So you did it from the outstation. What about testing the wiring of the dampers close to the dampers themselves behind the grill? Do you ever test that?
No.
Would you normally test that during commissioning?
No, we test it from control panels.
Did you perform an actuator operation check?
Yes.
Did you undertake an electrical check using a voltmeter?
Yes.
Is it right that 2 or 3 of the dampers, in fact, didn't work? You tell us that at paragraph 42 of your first statement. So RJE, the installers, were called back. Is that correct?
It is, yes.
Did you ever find out why they didn't work when you checked them?
I believe one of them was slightly out of alignment. These dampers work to tight tolerance, obviously, because they're supposed to be reasonably airtight. And if they're installed and, slightly tilted, they'll stick. The other two, I believe, had got old existing cabling that were hanging down inside the shaft. When the dampers were actuated open, it got stuck in the blade. So that was removed.
Right. The fact that was discovered, those problems that you just identified, did that raise any concerns for you about the quality of RJ Electric's work on the dampers?
Not really, because all the other dampers we had no issues, and we opened and closed these dampers probably 100 times before it were handed over in total.
Right. Did you raise these defects with JS Wright or the TMO in terms of what you'd discovered about dampers not working due to these problems?
With JS Wright, yes.
You did. And what was the response of JS Wright?
They instructed the company that installed them to take the grill covers off and find out why.
Yeah.
And I actually assisted, if you like. I was there when they did each one.
Yeah. And then did you retest the dampers again that
Yes.
RJE had replaced?
Yeah. Well, they didn't replace them. They just found out what the obstructions were.
I beg your pardon?
Yeah.
I see. Did RJE install all the dampers or just some of them?
All of them, to the best of my knowledge.
Yeah. Now, in terms of the level 2 dampers, can we just look at a photograph to help with this? We've talked about the dampers that were there at level 2 to shut off the environmental system and so that the smoke control system could work. If we go to BLARP 2, 5035, and at page 104, Yes, if we can blow up, this is a photograph, figure 4.18, of the horizontal fire-rated ductwork at level 2. And that ductwork was all at high position at level 2, wasn't it? It was,
Yes.
it was elevated up, yes? And can you help us then? How did you carry out the checks of the dampers that were in that ducting? How did you do that?
At the time that we were testing the fans and ductwork at level 2, which were probably on the second, possibly third visit in February, all that area was scaffolded out. So basically you could walk onto the scaffolding and the ductwork were at, well, slightly above my head height, but Gary was 6 foot odd.
Right.
So, and there was inspection hatches next to the dampers that were in operation. So we took the inspection hatches off. I operated the dampers from the control panel.
Yeah.
And then Gary radioed back to me to say whether or not it had opened or closed, what position it were in.
Yes. I understand you did that in February and that you had the assistance of scaffolding. What about at the end of the commissioning process, when you're supposed to be commissioning the whole and testing the whole system and checking it works properly? At that point, did you go back and did you check that those dampers were working properly at level 2?
No, because once they're working, and I can understand where you're coming from, but then all the readings that we took during the final week of commissioning, had those dampers have not operated, we wouldn't have got any flows.
Yes.
So we wouldn't have been able to take any readings. That would then suggest there's an issue, and yes, we would have gone back. I do believe the scaffolding in that area was still there right up to the very end.
I see.
I don't know when it was taken out.
Yes, but I think you've just confirmed that when you did the checks at the end, you didn't see the need to go back.
Because we'd already done it.
Yes.
We'd already done it. We'd proved that the dampers were working.
Yes.
Both manually operating them and then under fire simulation conditions on probably 15 or 20 different occasions. And then when we were taking readings on the final visits, had those dampers have not opened in either mode, environmental or fire, we wouldn't have got any readings.
Right.
And the door velocities would have dropped by probably half.
Yes.
So that would have suggested there's an issue.
Yes. There's a reason I'm asking about this, because both the BRE and Dr. Lane have expressed concern about whether or not those dampers worked correctly during the fire. So that's why we're exploring this particular...
They definitely worked, 100%.
Now, when checking the dampers, I think you've said that you were at the HMI panel and Mr. Doyle did a corresponding check that the dampers on all other floors where they should be closed were closed. How did he actually do that? Does that mean that every time you...
No, what would happen is, on the first morning, we would go up to, on a good day, in the lift to level 24. We'd come all the way back down and check all the dampers were closed. That's from me powering the system up when we got there.
Yes.
Provided they were all closed, we'd then start doing the testing.
Yes.
You've also got to understand that...
Sorry, just pausing there. I'm just going to interrupt you. So you say then you start doing the testing. I want you to focus on this question. If you then choose to test, say, level 4, okay, and you at the HMI panel, you trigger off level 4 or someone injects smoke into level 4, level 4 is supposed to open and all the other dampers are supposed to be closed.
Correct.
When you're checking level 4 and that those dampers have opened, would Mr. Doyle also go and check that all the dampers on the other floors had closed when level 4 was open? Would he do that?
Remained closed, is that what you mean?
Remained closed, yes.
No, because I used to plug my laptop in and monitor the software. Once you've proved that the software is working and no signals have been sent to any other floor, then they can't operate. They can only operate if they receive a signal to operate. And if I've got the laptop plugged in, I can see what signals are being sent out. So basically, if you initiate a detector on level 4, the only outputs that should activate are the dampers on level 4. If no signals are sent to any outstations for any other dampers, that's it, they can't operate. They haven't received a signal. But yes, we would have checked them every so often to make sure that ones that had been open had reclosed.
I see.
And when we did a floor-by-floor check, we did that for every floor.
Yes. Can we just look at something that Dr. Lane says in her Phase 2 smoke report about this at BLARP 2, 5035, page 281. And I want to look at paragraph 7.9.50 first. So Dr. Lane has considered in detail the functioning of this HMI panel. And what she said is this: the damper status on this screen is based on the most recent control signal sent to the dampers and not the physical state of the dampers at that time. See section 7.12 for details. Therefore, the damper status screen on the HMI panel could not be relied upon to verify the physical position, open or closed, of the dampers in each lobby of Grenfell Tower. It is not clear to me whether the persons carrying out the commissioning and maintenance of the smoke control system were aware that the damper status screen on the HMI panel was not based on an actual signal back from the damper to the HMI panel. Now, is that consistent with your understanding of the system and the HMI panel?
It is, but again, what you have to think is that if somebody's got to go up 25 floors every time we operate one floor, you know, so, I mean, basically a couple of times throughout the day, once we'd finished activating dampers, we'd get in the lift, go up to the upper floor, come all the way back down and make sure every damper were back where it should be,
Yes.
that none had remained open.
Yes. I appreciate that might have been a lot of work to check it manually, but do you accept the point that Dr. Lane is making there, which is you can't simply rely upon what the HMI panel's telling you, because that's only saying that a signal's been sent. It's not actually telling you that a signal's been received back from the damper with its status open or closed.
Yes, I accept that.
Yeah.
Can I just ask, do these dampers have any default modes? They're not spring-loaded or...
No, not these type, because these are smoke dampers, they're not fire and smoke.
Right, so they've got to be opened by an actuator
And closed
by an actuator.
Yes, yes.
Thank you.
Yes, you see, so one of the points that Dr. Lane has made is that, say, the fire brigade, when they were looking at this panel on the night, wouldn't have realised that this HMI panel, in terms of what it was showing them, was not actually showing them data from the damper itself, was just showing them what signal had been sent out to the damper. Do you understand?
Yes.
And she's critical of that HMI screen for potentially misleading the reader of that screen in thinking that you were getting reliable data back from the damper. Was that something that ever occurred to you when you were commissioning the system?
The dampers are quite reliable. Once you've proved that they're all working, and they only work when they get a signal to work, as with any other system, you've got to assume that that's how it works. And that's the reason why it's always, it's necessary to do maintenance checks. During those maintenance checks, that's what would happen again. You'd do a mini commissioning and you'd prove that dampers were opening and closing properly and matched up with what it said on the screen.
Again, sorry to interrupt, but if a damper got stuck, because they operate on a spindle, don't they, or something like
It's
that?
like a drive mechanism, yeah.
If a damper got stuck, presumably you would see on the panel that the signal had been sent to open or close it, as the case may be, but you wouldn't know whether it had responded to the signal.
No.
No. Thank you.
Thank you. Do you know why the system was not set up to provide real-time information about the state of the damper?
I don't know. I mean, damper monitoring, which is now more widely used, as, it's not something that, as far as I'm aware, it wasn't something that was required by any specific rules.
No, but are there systems that you're aware of that
Yes.
you've commissioned where you do have damper, what you just call damper monitoring?
Yes, we do now, yes.
You do now. And when you talk about now, are you drawing a distinction between what you did at the time of Grenfell and what you do now?
No, because we had damper monitoring on other sites where it's a different kind of system. It's basement systems where we monitor dampers,
Yes.
where it's multiple rooms in a basement, for
Yes.
example.
Yes. And can you give us any explanation as to why we didn't have any kind of damper monitoring at Grenfell Tower?
I didn't do the design, so no, I can't unfortunately.
No. Yeah. You see, again, the reason why I'm asking is after the fire, the BRE reported that certain dampers, not on level 4 where the fire was detected, at other levels, appeared to have been open when they shouldn't have been.
But again, you've got to remember that some of these dampers opened potentially 4 or 5 hours after the fire started, when the old building was encompassed.
No,
cables were being damaged.
Yeah.
You can't surmise and supposition regarding why a damper was open 4 hours after a fire started. You know, I mean, it's not normal conditions.
No, I take that point, but I think a slightly more investigation has gone into whether the damper was open from the beginning or not in terms of smoke patterns, etc. But I understand the point you're making. But can we agree that the lack of that feature, the lack of that damper monitoring, did mean that actually the commissioning process ought to have required a check each time of whether all the other dampers were closed, even though that was time consuming?
We did check every day at lunchtime and at end of every day. We would go up to the top, come all the way down and make sure that when we'd reset the system, every damper was closed. And then we'd do that at the start of the next day, and then we'd operate dampers. And as we operated dampers and went from level to level, testing fireman's override switches or even from the HMI, we double-checked that the damper on the floor we'd activated closed, as well as the damper on the next floor activated opening.
Yes, I see.
And none of the other dampers should operate because they haven't been given a signal to operate.
Well, I realise they shouldn't operate because
No.
they've not had that signal, but as the chairman's just pointed out, you could get a damper that got stuck because you
could,
opened it earlier,
yes.
and it's not been able to close,
Yes.
and you haven't picked that up because it's on level 23 and no one's been up there for the last few tests.
Yeah,
That
but
could
at
happen.
the end of the day, I would check all them dampers again on the way back down, make sure they were all closed.
Yes.
So yeah, we did do it a couple of 3 times a day,
Okay.
but not every time we operated a damper because we'd have to go up and down 25 floors every time we did one damper.
Yes, no, I follow that. Can we go back to the PSB commissioning report, PSB 50224, and look at page 3? So this is in the commissioning report. And in terms of the dampers, we've got CD01 and CD02, which you've been helping us with. We don't get CD03 and 04. They're not shown in the table. Now, you tell us in your statement, this is paragraph 38 of your second statement, that CD04 was a permanently open vent, not connected to the system and was effectively redundant. What about CD03?
It was held open. It was mechanically, not connected electrically, and the damper was driven into the open position and left in the open position.
I see. So
There's
that's
no
why-
wiring to it, so it was never ever going to close again.
Right, so that's why they don't appear on this commissioning report.
They're not on any of the tables for the wiring, for the connection sheets, control panels. They're not there. They don't exist.
Yeah. Now, if we look at paragraph 107 of your first statement on page 18, you tell us that you also took the following readings at the grill covering each damper on each floor. And you say that it was when the system was operating in smoke control mode and the fans were operating at low speed, the door to the stair was closed. When the system was operating in smoke control mode and the fans were operating at high speed, and when the system was operating in environmental mode. So you took readings actually at the grill for each damper, is that correct?
Yeah.
How many readings did you take at each damper grill? Do you remember?
Possibly between 4 and 6. They were only this big, so it's very
Yeah.
difficult to. You know, you've got to be about 300 or 400 millimetres away with anemometer as well. So
Yeah. And where you've got two, say 2 for the south, half 2 for the north.
yeah,
you do
doubled
both.
up. Yeah. So you're taking like 8 readings all told
Yeah.
on the south shaft, 8 readings all told on the north shaft.
Can we just look at some emails that were being sent about additional readings that were being requested? PSB 401129. I want to begin with the third email down from Mr. Hanson, dated the 4th of May 2016, at 8:43. So in this email to Mr. Hughes of Ryden, he says, "Hi David, the figures you've sent do not appear to be extract readings. They should be in meters cubed per second. The readings you sent are velocity readings in meters per second." And then he says, "Remember that the testing of the system we're witnessing tomorrow should be in accordance with section 9 of the SCA guide." Okay, so he's asking for extract readings in meters cubed per second, not meters per second. And then if we scroll upwards, we can see that later that day, Alan White then contacts David Bradbury, asking for his help with this. Alan White says, "Dave, can you help me out with this, Alan White?" And then if we go upwards, we can see then David Harrison says to David Bradbury, "Hi David, building controller asking for the meters cubed per second readings. Are you able to provide, please?" Now, do you remember this happening whereby building control were asking for extract readings in meters cubed per second rather than meters per second?
Yes.
Now, is it right that the anemometer was measuring velocity and not volume flow?
Correct.
Now, to your knowledge, were the cubic meter extract readings being requested here ever provided to building control?
They were never provided to building control. When you do meters cubed per second, you're doing that because you're looking for a volumetric reading in meters cubed per second, so that you can work out the area of the lobby, work out how many meters cubed per second you're extracting,
Yeah.
and then calculate from that how many air changes per hour that you're changing in that lobby.
Yes.
On a car park system, you would measure the grill, work out the percentage of loss along the grill faces from the damper, and you would come up with a calculated figure that gives you meters cubed per second, and then that is converted into meters cubed per hour to make sure that you're changing the air in that car park a minimum of 10 times per hour.
Yes, I understand.
For that lobby, for meters cubed per second, it wasn't part of what we would normally read.
No.
And when we did do them, and I did do them based on the door being approximately 1.9 metres square or, area, and then the door velocities that we'd measured, and the number of air changes per hour in that lobby were in hundreds.
Yeah.
But it wasn't a reading that we would normally expect to be asked for on an above ground system.
I see.
We quite often take readings of the fans to make sure that they meet requirement, but usually by taking the door reading and knowing that the door is, say, 2 metres square and that the fans are discharging through 0.6 of a metre square at 7 metres a second, when you work the two out, that tells you that your fans are working at full velocity.
Yeah.
So the meters cubed per hour, I didn't understand why building control were asking for that. And I do know David spoke to you, Marnie, and asked him, and he'd never come across it before.
Right. Let's look another, just to complete the picture, another email on this, PSB 401164. This is an email from David Harrison to David Bradbury. I think it's the one at the bottom of the page. Sorry, can we just go down the page to the next page? No, I think I must have a wrong reference. Yes, there's an email, perhaps I'll just summarise it. Yes, sorry, that's it, there, at the top of the page, from David Harrison of PSB to David Bradbury of JS Wright, 8th of June. And he says, "Hi David, we've received your correspondence and would comment as follows. Point 1, an anemometer measures velocity and not volume flow. As far as I'm aware, there are no products in the marketplace which can measure the volume flow rate, but I might be wrong. Should additional tests be required by the building control, we are unable to accommodate the request on this occasion. I suggest you contact a specialist organisation to fulfil building control requirements. And then at 2, we do not understand why they will not accept the simple calculation we have put forward, as this is a standard format in our industry, not to mention the standard method in the HVCA industry. Now, do we take it that there was in fact no additional testing done by PSB to obtain these volume readings?
There was no additional testing done, but as I said, I asked for the door areas that were all the same, basically. I asked for somebody to measure, well, I asked Alan White to measure one of the doors, give me the area, and then based on the velocity across the open door,
Yes.
average velocity, we'd be able to calculate what the volumetric was in metres cubed per second.
Yes.
And I did do that, and I also calculated how big the lobby was, and I think it came out at 140 some air changes per hour.
Yes.
And it was 10 that was required. But 10 air changes is, again, it's a nominal figure. In a car park or an underground basement system, it's a figure that you have to react to. On an above ground system, it's not
Yes,
something that's mentioned.
I understand. And I understand you didn't understand why building control wanted these readings.
It was the first time it had ever been asked.
Right.
So I didn't understand, no.
Can I just understand, did you understand that it was volume readings for the volume of air across the stair door that was being requested, or volume of air being extracted at the damper points?
Well, it's one and the same thing. Whatever's coming through that stair door, if you work that out as a volumetric reading, that reading is going to equal what the two fans are extracting.
Right, I see.
Because it's what goes in, comes out, you know. So
I understand.
if you work out the door volumetric reading, that's what the fans are doing.
Yeah. Now, the SCA guide, looking at that list at 9.6 again, this is at RBK 402932, page 59. RBK 40, yes, thank you. The second bullet point is to check that the fans were operating at the same times as the opening of the dampers, measure its performance, and check against the design value. Now, at paragraphs 72 and 73 of your first statement, you explain that you connected the fans up to the master control panel, and then you set a damper timer function. Is that correct?
Yes.
And if we go back to the PSB commissioning report, this is PSB 50224 at page 3. In the final table, we can see, in relation to fans, it says towards the foot of the final table, 2 items up, fans times 5, damage okay towards the right, pass yes. Now, there's no record of actual measurement of the fans here, is there?
No. The fans, each fan, when it's delivered, has a fan data sheet. The fan data sheets are left on the fans. I checked the data sheets when I was checking the fans. A, to make sure that the fans were fire rated, and then the data sheet. The data sheets supplied also give you the fan velocities and volumetrics that they're going to meet a set pressure. And when you add the two together, it's about 5 metres cubed per second. For us to get 3.5 metres cubed per second at the door, those fans must have been achieving that level of extraction rate. Otherwise, we would never have got the figures.
Yes.
So the figures that you get at the door match the added together figures of the extract fans at level 2 and roof.
Yes, I see. But just to be clear, did you actually ever measure the actual fan performance yourself?
At the grills and at the dampers and at the doors, effectively, yes.
Right, I see. So you're saying the tests you did effectively did measure that?
Well, it's giving you the same result, yeah.
Where was that recorded, if anywhere?
On that sheet that says the fan velocities at the door and at the grills, at low speed, high speed and environmental.
I see. So because you've got the metres per second readings.
The fans are also charted in metres per second
Right.
as a velocity
I see.
through a set diameter, which you can then calculate into a known cubic metres per second.
Yeah. Now, you tell us in paragraph 81 of your statement that you checked that the HMI panel was displaying that the fans were running and on which level smoke had been detected. And then in the next paragraph, you tell us that Mr. Doyle checked that the fireman's override switch on each floor was working. Can you just explain to us how did he check that that switch was working on each floor?
Well, initially, when we were dead testing the system, I'd be at the control panel or outstation. Gary had turned the switch, say, right, it's on. I'd look to make sure that it had changed state from open to closed. He would then turn it back. I would check that it changed state from closed to open. That's dead testing. Then once you've started powering the system up, we would activate a smoke detector on, say, level 1. We would then go up to level 2, turn the key switch and make sure that it changed from venting on level 1 to level 2.
Yes, I see.
So that's, you're duplicating the tests you do multiple times.
Yeah.
But you're duplicating it to make sure that the software is correct.
Yes, I see. Now, the next check that the SCA guide recommends is check the automatic changeover is operational for the secondary power supply. Now, did you ever make sure that the automatic changeover was operational for the standby fan, either at roof level or level 2?
For all fans, at all speeds, at all levels, in fire mode and in environmental, and that was demonstrated on the final demo I did in April. So basically we had the fans running, we had the system in fire, with a fire activation at level 1, and then the RJK or RBK, whoever it was, electrical guy, switched off the primary power, and the system went over to secondary power and carried on in fire mode. We also did the same thing at roof level, and we did it in environmental mode to then switch on the secondary supply at both levels when we then instigated a fire signal. We also checked that when the main fan at roof or ground, at, well, level 2, if that fan stopped working by simulating no power, that the backup fan initiated and started running.
And were you actually, at that point, were you, when you were doing this towards the end of the process, were you actually able to see whether the backup fan had started up at level 2? You could,
yes. I was up at level 2 doing it, and then up on roof doing it.
Now, pressure switches, the SCA guide also requires that where applicable, the operation and function of the pressure sensors should also be checked. And you tell us in your statement that you tested a number of different components. First, you say that you checked the pressure switch was mounted correctly in the staircase and the lobby and that it was connected properly. And you say you also checked if the pressure switch activated, if the air resistance changed by means of sucking air through a piece of pipe and attaching that to part of the pressure switch. Is that correct?
It is, yeah.
Does sucking air through the pipe enable the calibration of the switch to be checked?
No, but, and you don't, it's when you say sucking air, it's a very, 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 just without even a closed mouth around the tube. So if you can't just do it too hard because you could damage it. So it's the lightest possible pressure or vacuum applied. If it doesn't activate and we don't see it change state, then obviously they've got the pipes the wrong way around. So they've got the negative side on the stairwell and the positive side in the lobby by mistake. Just a case of making sure that they were all piped up the right way.
Yes. Yes, I understand.
And then once you've got past the point where you've actually got power, opening and closing the door simulates exactly the same thing.
Yes.
So you just all the time, you're just checking and checking and checking.
Yeah. The point, you've anticipated the point I wanted to put to you, because Dr. Lane notes that the manufacturer's recommendation for the pressure switch says that the switch will be damaged if subjected to excessive pressure. Do not test the unit by blowing into the inlet ports. That's what the manufacturer's literature says.
I don't put my lips round the tube and blow as hard as I can, or suck as hard as I can. I literally do that. And it's not actually in my mouth, it's in front of my mouth, and I'm creating. 1 Pascal is, so I'm not stupid.
Yes.
There isn't a device out there that can simulate it, that's the problem. The manufacturers tell you don't this, don't do that, but they don't give you a device that can test them.
Yes. Now, just in terms of checking other individual items in the wiring, if we go to paragraph 36 of your first witness statement on page 7, in paragraphs 36 and 37, you explain that during the second stage of your visits, you identified each individual item of equipment and checked it was wired correctly. And that was done using the board assignment sheets, is that right?
Yes.
Now, can we just be clear, did you check every item of electrical equipment or just a selection?
No, everything. So that's the card, the connections between the cards, the connections between the floor below and above if necessary, all the pressure sensors, all the fireman's override switches, all the dampers, all the smoke detectors.
Yes.
There's nothing else on it to check.
Can we agree that the commissioning records don't show that you tested each electrical device? So that would be all 24 pressure switches, 26 yellow key switches, the operation of the HMI panel, for example. Should that have been recorded?
It is recorded. It says pressure switch 01 to 24, tested, operate, OK.
Right.
So that's, I could have done better, and I could have highlighted 24 switches, a single line per switch, you know what I mean, and 24 FOSs, a single line per switch. It'd have been a 1,000 pages document. I was given a very short time in which to get this back to the client for them to be able to present it to building control. Normally it would have not as been, the final document would not have been as concise as the one that was.
Yes.
But it does actually say on there, and if you look at the latter pages, it says primary and secondary supplies tried, main and backup fans tried, under failure.
Now, one of the things that's been noted about PSB's documentation is that in technical submission revision 6, that indicated that the fireman's override switches were to be installed in the stairwell on each level, but on PSB's electrical schematic, they were shown in the lobbies. Now, do you remember noticing that there was a discrepancy on the documents as to whether those yellow key switches needed to be in the stairs or the lobby?
No, I didn't notice at the time, because I'm reading a drawing that says it's in the lobby, and it was just inside the edge of the door, so literally as the door opened it was there. And yes, normally they are in the stairwell, but there are sometimes when they're put just inside the lobby for safety reasons with vandalism and stuff like that. But no, at the time I didn't notice it because it was where the schematic said it was.
Yeah, so you didn't notice that in the technical submission it was said to be in the stairwell?
Not until afterwards, no.
And when you say not until afterwards, when did you first notice that there was that discrepancy?
Probably after the fire, when I was reading through all the documents.
I see, okay. And did it ever occur to you that placing the switches in the lobbies rather than in the stairwell would make those switches particularly vulnerable to increased temperature from fire and smoke? Did that occur to you at the time?
It didn't, but then having said that, the switch was mounted just inside the door, so if the level that was on fire, if the door was opened, you would have had 2 metres a second of cold air blowing over it. And I can understand what your point is, that because this fire then encompassed multiple levels, it did create damage to the switches, but I mean, it damaged everything else. Concrete, floors, everything.
Yes, I see. Now, some questions about checking power supply and control panels now. If we look at paragraph 46 of your first statement on page 9, this is about applying power to the system. You said the next step was to get a power supply to the master control panel located in the hub room and start the system up operating through the outstations. And if you go to paragraph 62 of your statement on page 11, you say that in this paragraph, you tell us the next step was to check the connectors to the inverter panels, which controlled the speed of the fans, make sure they were receiving the correct power supply. And you tell us in the following paragraphs that you then connected the master control panel and connected and supplied panel to the PLC unit and the HMI panel. Did you ever check the system's secondary power supply?
Yes. Turn the primary off.
And as part of doing that, did you check that all the 24 outstations and both fans were operating and providing the required volume rate of extraction under that secondary power supply?
Yes, but what you've got to remember is there's not just the primary and secondary supply that are referred to are 400 volt for the fans. So that's a primary and secondary supply within its own right. That was at roof level and the hub room inverter panels. There was also battery backups within the inverter panels to the master control panel, and then battery backups every other floor for the outstations.
Yes, I see.
So there was multiple reserve supplies. It was more redundant supplies available in the event that you lost power at one battery backup unit. You would still get power to the other two from the other two above and below it.
Yes.
But the main power supply was for the inverters and the fans.
Yes.
And all these were monitored.
Yes. Now, the British Standard 12101 Part 6 requires that all doors to the depressurisation zone, so here that would be all doors to the lobby, shall be self-closing, yes? Did you ever ask whether all the doors to the lobbies were self-closing or perform any kind of checks of that?
All the stair doors had closers on. Not all of the doors closed properly, so I did report that fact to probably Alan White.
When you say, pausing there, not all of the stair doors closed properly.
They closed, but they might be just on the edge of closing because, you know, it could have been a bit of a seal or a...
Yes. Do you remember how many doors you reported that problem for?
There weren't that many. On the stair doors, possibly 2.
And what about flat doors? Did you ever ask anybody whether the flat doors were all self-closing?
No. We were asked from day one not to upset residents, basically. So I wouldn't knock on somebody's door and open it and then see if it closed on its own, unfortunately. What I can say is there were numerous doors of numerous types throughout the building. They should have all been fire doors. But that, again, is... I'm commissioning the system, not the building.
Yeah. Now, the shafts and the builder's shafts that the air flowed through, the north and south shaft, and indeed the ductwork, the new ductwork at lower levels. Did you, in terms of the existing builder's work shafts, did you ever check whether there'd been any previous testing which had determined the leakage rate of the shafts?
No. That testing should have been done by the people that installed the ductwork when it were installed. And as for the existing builder's work shafts from 4 upwards, the shafts were inside apartments. They weren't external. It was not something that I could look at apart from up at the top, and by going up onto the roof, lifting the cover off, I could look down through the fan, and it's not really telling me a great deal.
Could you have done any tests to measure the leakage of the shafts as part of the commissioning of the system?
Not on that system, not easily. No. I
When
mean,
you
the only thing is if you've got a lot of leakage on those shafts, then you won't get the velocities on the doors, you won't get the velocities on the grills, so you won't achieve the readings that you're required to achieve. You just won't get it.
Yes, I see. Okay. Now, in terms of changes to the design, the British Standard BS 47346 Part 8 that we looked at earlier says that during the commissioning, the entire system should be inspected and tested, including to ensure that no changes to the building have occurred since the time of the agreed design, which might compromise the system's conformity. Were you aware of the need to look out for any changes which might affect the system's performance?
As far as I was aware, the system that was installed when I visited site was the design system, i.e. the changes from level 3 down through to 1 and ground. As far as I was, my understanding is those design changes were part of the design system. So, no, I had no reason to suspect that they'd cause a problem.
I see. If we go to PSB 401113, this is an internal PSB email to you from Michael Glowacki to you on the 25th of April 2016. And what he's doing in this email is informing you about certain environmental programme changes that were being provided to you. So he said, please find attached files before you download programmes. Please make sure that environmental node is not active, or you may burn the environmental fan motor. You'll have to set up environmental sequence and environmental fan speeds. So he's giving you various changes to the environmental programme system. Is it correct to say that these changes are not reflected in PSB's commissioning report? The modifications box in that report is empty. But we know from the documents that a new environmental programming and a new environmental fan inverter was installed at Grenfell Tower immediately prior to the formal commissioning process. Did you ever consider with those changes, whether those changes to the previously agreed design would affect the system in any way?
The changes were the speed control on the environmental fan was a fixed speed. And unfortunately, when they installed it, they didn't install attenuation. So with that fan running at fixed speed, full speed, in environmental mode, it was far, far, far too noisy. So they asked us, could we help them out? And the only suggestion I had was to fit an inverter on it and run it at much lower speed, which would reduce the noise. So the change was purely on speed control. It wasn't part of the system as such. The rest of it more or less stayed the same as it had been intended to be from the beginning.
I see.
As far as I was aware, the environmental system was part of the system when I first went.
Yes, I see. So you didn't think that these changes needed amendments to be made to the commissioning documentation?
Potentially you could have done, but at the end of the day it was just speed control. It wasn't the way it worked. It was still environmental system from a temperature controller supplied from BMS and operating dampers on multiple floors for a set period of time between certain times of the day.
Yes. Can we look at a TMO document now? TMO 100-21425. We can see what this is a call-out repair visit certificate from Allied Protection, who by this point were in May 2017. We can see that's the date of this document. They were maintaining the system, and it was a call-out to Grenfell Tower about a loose coil in the roof area. If we read it, it says, under details of any deviation from the working system, Grenfell Tower call-out, FP cable is coiled up in the ceiling, awaiting for a smoke detector to be fitted by other engineers from another company. So it would appear that there was some kind of coil which was waiting for a smoke detector to be fitted to it. Can you just help? I know this is a while.
It was a coil of FP cable that was at the top of the stair that took you to the lift room, and it was sat on a beam, and it had been there for quite a while.
Right.
Assumption being is it might have at some point been something to do with the existing fire alarm system or the lift fire alarm system. It was nothing to do with the PSB system.
Okay.
There was also a second coil in the roof fan room
Yes.
that was next to the fans that was originally intended to operate the shut-off damper at roof level, which was never installed.
Yes. Okay, that's helpful. So you do remember that cable
I
being
remember
sat
that
there?
cable, I saw it a few times, yeah.
Yeah. Did you ever ask for it to be removed if it was nothing to do with
Nothing
the
to
new
do with-
system?
No, it's nothing to do with it.
No, I see. Mr. Chairman, I anticipate I've got about 10 minutes left of questions till the end of my questions. I'm in your hands as to what we do. I could ask.
Well, I think if you can finish your questions in 10 minutes, it would be sensible to do that.
So I'll just keep going for now. Thank you.
If you mean 10 minutes.
I'll try. So now I want to go to ask you some questions about the demonstration that was done on the system on the 28th of April 2016. If we go to paragraph 112 of your first witness statement on page 19. You tell us that you recall that you attended Grenfell Tower on the 26th to the 28th of April 2016 to carry out final checks of the system and formally hand it over to Alan White of JS Wright. And then at the next paragraph, on the 28th of April 2016, you were asked to attend a demonstration of the system. This was organised at the request of JS Wright. So far as I was concerned, this was an opportunity to demonstrate the system to PSB's client, JS Wright. PSB was also informed that representatives from building control would be present. In the event, a number of other persons were also present. To the best of my recollection, this demonstration included Alan White from JS Wright, representatives of Ryden, 2 people from the London Fire Brigade, someone from the management company, and at least 1 building control officer. I cannot recall the names or job titles of these individuals. And then in your second statement, at paragraph 47, we don't need to turn it up, you've clarified that having considered some documents from JS Wright, you think that the attendees are more likely to have been basically the people you cite there, but no one from building control. Is that correct?
Yeah, I mean, I was asked to do a demonstration on a certain day at a certain time, and I was told loosely that certain people would be there. I believe there were a couple of ladies there from TMO or whatever it's called. There was a fire officer, fire station manager, and 2 fire officers who were also there looking at the dry risers. I believe there was a couple of guys who were like caretakers, and they would be like keeping an eye on the system.
Yeah.
There was a representative from Ryden, JS Wright. I believe there was somebody from Maxford. It was about 11 or 12 people in total.
Yes.
I listed a few names then. I genuinely thought one of the people that was going to be there was building control.
Yes.
Because that's the whole idea of the demo.
Yeah. And if we go to paragraph 118 of your first statement, page 20 now, you say that to show how the system was activated, a cold smoke from a can was sprayed onto the smoke detector head in a common lobby. Those present were then able to see the system engage with the common lobby door closed. And that door was then open, so you could demonstrate how the fans would ramp up at that point to ensure the airflow from the stair to the common lobby, which would continue to prevent the smoke entering the common lobby even when the door was open. I can't remember precisely now, but I believe we demonstrated the system on a number of levels in that way. Can you remember roughly how many levels you demonstrated the system on?
Something like 1, 7, 11, 16 and 23.
Right.
Several levels. And at some point on level 1 we tested the auto changeover on the main power, the 400 volt for the inverters. And we did it again at roof level. When we did the highest level, we switched the primary supply off so that the secondary would kick in.
Yeah. And can you explain what was the reason behind the choice of some floors and not others? Was there a rationale behind the selection or just a random sample?
I just asked the client, which floor do you want to do? And if he says all 23, I do all 23.
I see.
If he says do this one, we'll go up 6, we'll go up 6. I do what I'm asked, basically.
Yes. Now, the SCA guide includes a requirement to carry out a cold smoke test if appropriate. And then it says generally only for systems used to allow extended travel distances. That's under 9.3.5 for mechanical shaft systems. Now, PVE, a provider of cold smoke test equipment, have explained that using a smoke machine can help evaluate the system's efficiency and identify any dead spots in the system. Now, did you ever consider using a cold smoke machine to test the system more thoroughly?
It wasn't considered simply because the only way you could test it would be to carry the smoke machine into somebody's apartment, set the smoke machine running, close the door, let it fill that apartment with smoke, then open the door, let it activate the detector, and then open the stair door as though you were escaping and see how much escaped onto the stairs. To do that in an occupied building, it's probably very frightening if somebody walks out of their flat door and they're confronted with a lobby that's full of smoke.
Was there ever any discussion about performing that kind of test?
I would have considered it quite dangerous under the circumstances.
Right, because our building control expert, Miss Menzies, has said that that was the common way she would have expected.
In an unoccupied building, it can be done. If you haven't got a CFD analysis, then one way of proving it is take a smoke machine along, and if it's a corridor system, put it in the corridor, fill the corridor with smoke, activate the detectors and make sure that it does what it's designed to do.
Yeah, well here we don't have a CFD analysis,
No.
and we don't have this kind of more comprehensive smoke test, but as far as you were concerned, that was never discussed with you, is that right?
No. The door velocities should suggest that smoke would not travel in reverse direction towards the stair. That velocity of 2 or 3 metres a second, smoke can't travel against the wind effectively.
Now the HMI panel in the lobby, did you demonstrate the various messages on that HMI display panel to the fire brigade, and did you explain to them what they all meant?
Yes.
Did you explain to them how the messages fire detected on level X and fireman's override key available? Did you explain to them how they would appear on the HMI panel?
Yes.
Did you show the fire brigade what to press on the touchscreen if those messages appeared?
Yes. And we activated it when we did the ground floor, so I went through that part of the process because that's the level we were on.
Yes. Now, if we can look at Dr. Lane's Phase 2 report, BLARP 2, 5035 at page 287. I want to look at paragraph 7.10.14. So in this part of her report, what Dr. Lane has done is analysed the operation of the HMI panel and compared it with the instructions that were provided. And she notes that if a user inserted the key in the HMI panel and turned the system from auto to on, 3 options would appear as shown in figure 7.31. That's the fire brigade override screen. And one issue that she identifies is that the instructions do not indicate what each of these 3 options do. And one says turn system off, one says restart system, and one says go to individual floor control screen. And in particular, if we then move on down the paragraphs at page 288 to paragraph 7.10.17, what she's identified is that the instructions don't make clear that a user had to turn off the yellow key switch at the floor of operation where it had been manually operated by the fire service before another yellow key switch could be operated to change the floor of operation. And the instructions also don't explain that the yellow floor override switches took precedence over any manual control from the HMI panel itself. Now, first of all, do you agree that that's how the system was designed to operate?
Yes, and I explained that system to the fire brigade when I was explaining it. As I said, we activated a smoke detector at ground level. We then went outside the door. I showed them on the screen where it said fireman's override key available, fire detector ground floor. I then turned the key and that screen comes up with your 3 options.
Yeah.
I explained option 1, turn system off, option 2, restart system,
Yeah.
option 3, go to individual floor screen.
Yeah.
Tapped that screen and showed them that it then allowed them to vent from so many floors. And then if you wanted to go to the next bank of floors, there's a little button at the bottom of the screen said next levels.
And did you explain that the yellow floor override switches would take precedence over any manual operation of that panel? Did you explain that?
Yes, and I also told them that if you left the key in, you would also get a message on the HMI saying key activated.
I see. And did you tell them that before another yellow key switch could be operated to change the floor, they had to take out the key that had been operated on the first floor?
Well, I've just said that, but
Yeah.
actually there should have only been one key that fits the HMI, and it's a different key, and then one key that the fire brigade can take floor by floor.
I see.
If they put that key in and turn it and activate it, you've got to turn it back before you can either use that screen or go to another floor. And if you try to do it on another screen, it'll give you a message says key switch active.
Yes. In general terms, wasn't this quite a complex set of instructions and controls?
They're all
for the fire
complex
brigade?
because they want a system that can do a lot, if you know what I mean. The clients want a system that can do virtually everything.
Right.
So it's a complex system. But again, I asked the fire station manager, whatever he was, I asked him, did he need any more explanation?
Yes. Dr.
Can
Lanes,
I just ask, did anyone make available a written set of instructions?
If we're asked, well, we do have a set that we do issue normally, or sometimes we do, but the ones that were in the box where the HMI was at this particular place, I believe was done by JS Wright. I might be wrong, but I believe they were. And they would have asked us for some instructions.
So you think something was provided in
There
writing?
was some instructions at the side of that box. I've
Yes.
seen a photograph of it. I
Yes,
don't know
they-
exactly what it said because it's a bit blurred.
Right.
we've got those. Those have been analysed. They're very simple instructions.
Yeah.
Well, they may be, but I was just thinking that the fire brigade could probably be provided with sufficient instructions for them to go away and read them and think about them and then possibly come back and have another look.
I mean, I discussed it with them, went through it, and I did say, if you need any more information, just give me a ring.
Right. Thank you.
Dr. Lanes also explained in this section of her report that if a user had turned the system off and then selected restart the system, this would restart the system's fans and dampers on the original floor where fire was detected, regardless of where a manual yellow key switch had been activated elsewhere. Again, was that your understanding of how the system worked?
If she says it will like that, then yes. And yeah, normally it's a restart, it goes back to where it began.
But was that something, it doesn't sound like that was something that you would have explained during the demonstration of the system, no?
Possibly not, no.
No.
I try to keep it reasonable because it's a complex system. So I do try and keep it simple in the same way that when you're explaining it to the caretakers, etc., the environmental system, don't make it too complicated. And always say, there's a phone number there, if you need us, ring it.
Yes. Now, you say at paragraph 115 of your first statement that this 28th of April 2016 demonstration was a detailed demonstration taking some time. Can you recall roughly how long did the demonstration take?
Hour and a half, 2 hours. I really cannot remember. We were up and down the building several times. We were up on the roof. You know, we were in the hub room. We were on various levels. Then stood by the HMI discussing it. I couldn't really say. I mean, it could have been an hour, could have been 2.
And we know that there was a second demonstration for the building sometime later on the 5th of May 2016. If we look at PSB 401129. So we know that on the 5th of May, there was a demonstration attended by Alan White from JS Wright, Matt Cross-Smith from Matt Fordham, and some testing being witnessed by Paul Hanson of Building Control. And this is the emails they're exchanging the day before setting that up. Is it right that you were unable to attend this demonstration with Building Control?
Yeah, I was commissioning another building.
is it usual for the commissioning engineer not to attend the visit where the system is demonstrated to building control?
It's not normal. Normally, I would do that demonstration. As I said, I thought I had on the 28th of April. I didn't realise that building control hadn't attended. There was a lot of people there.
Yes.
And I just assumed that the building control officer were available.
Did you otherwise meet with building control at any other time during the commissioning process?
Not that I can remember.
No.
No.
Then finally, training and maintenance. If we go to paragraph 150 of your first witness statement on page 25, you tell us in there that you returned to Grenfell Tower in May 2016 to provide some training on the operation of the system, but you can't recall now precisely when that was.
That could be me just getting mixed up. After the 28th of April, I don't really remember going back. So
Right.
I don't know why I've said that, but I did do some training with caretakers. So whether that was before or after that, I don't know.
Yes, because in paragraph 48 of your second statement, you say that there was a demonstration to staff from the TMO. And we just wanted to ask whether you can recall who that was delivered to and what it had involved.
I can't know.
No.
I believe it were 2 guys and 2 ladies, I'm not sure. Or 1 lady and 2 guys, and I believe they were caretakers. But what date I did that, I really can't remember.
And were the LFB there at that time, the fire brigade?
I don't think so, no.
Yes, and I think you've answered this because the chairman's just asked you, but to your knowledge, was the fire brigade ever provided with written instructions or a manual for the operation of the system, either at the April demonstration or on any other occasion?
No, they were given a verbal and visual demonstration at the end of April, and obviously, same again, you just, ask them if you need anything, any information, just let us know and we'll provide whatever you ask for.
Yes. Now, in paragraph 151 of your first statement on page 25, you say that in or around May 2016, the WIT UK group sent a proposal to JS Wright for a maintenance contract, but that this wasn't taken up. Is that correct?
As far as I'm aware, yeah.
And you then tell us, this is paragraph 152 for the transcript, that PSB were next contacted with a report of a potential fault on or around the 6th of June 2017, and a quote was requested on the 12th of June 2017 and provided that same day, and you've said there was no response to the quote. Were you involved at all with any response to that fault?
No, that would have gone through the WIT UK part of the company, which they do all the maintenance and servicing, which by that time I wasn't even involved in anymore.
Yes.
I used to be prior to that, but it was run by Richard Thornley, so no, I had nothing to do with the quotes, apart from, I know the original quote would have gone out for the maintenance contract in 2016 or whatever it was.
Now we know that fault, just before the fire, was a fault with the environmental system working properly. In his evidence to us, Mr. White of JS Wright has said that the environmental system may not have operated properly at that time because the air temperature wasn't high enough for it to activate. That's at paragraph 196. In your opinion, knowing how the system worked, is that a possible reason why the environmental system might not have been working?
It could have been, but the environmental system, you could turn it off, you could set it to come on at 8 in the morning, turn it off at night, you could select summer, winter, so if you selected that other screen, it won't matter what temperature it got to, it won't activate.
Now, if there was a fault with the environmental aspect of the system, to what extent could that have affected the system operating in its smoke control function?
None at all.
Not at all, thank you. Mr. Chairman, I've come to the end of my questions. Sorry, slightly more than 10 minutes, but I think it was worth doing in one run. So perhaps if we could have the usual afternoon
You will have a break, yes.
And then that should be enough time to sweep up any additional questions.
I think so, yes. Thank you. Well, Mr. Partlow, we're going to have a break at this point. We'll come back, please, at 3:45, and at that point we'll see if Council has any more questions that need to be put to you. All right?
Yeah, no problem.
Again, while you're out, please don't talk to anyone about your evidence.
Nobody comes to see me.
No, I don't think you'll have much of a chance, but if you do, don't take it. Thank you. Right, thank you. Course to form in this
Thanks.
case. Okay. Would you ask Mr. Partlow to come back in, please? Right, Mr. Partlow, we'll see if there are any more questions for you. Yes, Ms. Grange.
Yes, thank you. Yes, just a couple of brief questions. Earlier in your evidence, you referred to the dampers as smoke dampers. Did you ever ask yourself the question when you were doing the commissioning whether the dampers were rated as fire dampers, fire and smoke dampers, or smoke control dampers? And what did you think they were?
Well, the Gilbert's dampers supposedly were smoke dampers and tested to 3 hours at 300 metres cubed per hour at 50 pascals or whatever. So as far as I was concerned, I've always understood that Gilbert's dampers were smoke-rated dampers.
When you say smoke-rated, do you mean smoke control dampers?
Well, yeah, for smoke control systems.
Yeah. And did you understand there to be a difference between fire dampers, fire and smoke dampers, and smoke control dampers?
Fire dampers tend to be spring powered in one direction, generally closed, and also the fire and smoke ones tend to have an inbuilt thermostat set at about 80 degrees C. So if they detect an increase in temperature, the damper automatically closes to shut off the compartment that's, you know, to stop fire spreading within ductwork in compartments, basically.
Yes, thank you. And final question, we talked about whether there was ever consideration of doing a more comprehensive smoke test, and you talked about the fact that in some tests you might fill a compartment with smoke and then open the doors and see where the smoke paths were, see whether there were dead ends. Did you ever consider, or did you discuss with anybody, using a void flat, a flat that was empty, say flat, I'm told, flat 145, you wouldn't know it was that flat, but did you ever have a discussion with anybody about using a void flat for that purpose?
Because you would, to simulate a flat fire, you would have to put the machine inside that flat. Then you'd have to fill it with smoke for a few minutes, then effectively open the door as though you're escaping, and trigger the detector, and then open the stair door, and at that point the fans will have ramped up to full speed, and you would be able to look and see if any smoke got pulled out when the door was shut, was any leaking back. But again, if you've got one flat that's empty on one level and 5 that are occupied, if somebody came out of that occupied flat, walked into a
well, of course,
a lobby full of smoke, but
you'd have to make it a proper fire drill or some kind of fire drill.
But I think the problem at Grenfell was there was a little bit of, I don't know, I just got the impression that the residents weren't happy with the amount of work that had been done and what they'd had to put up with over the previous 2 years, whatever, I don't know.
Right, and where did you form that impression from?
Because I was asked not to upset anybody when I first went there. You know, try not to make residents unhappy by using lifts and things like that.
I see. Okay. Thank you very much, Mr. Partlow. It just serves for me to say thank you for attending today and assisting us with our investigations.
Thank you for allowing me.
Well, Mr. Partlow, I'd like to thank you very much on behalf of all the 3 members of the panel for your coming here today to give us your evidence. It's really been very interesting and very helpful to hear what you have to tell us. So your evidence is going to be very helpful.
Thank you.
And we are very grateful to you for coming along. So thank you very much, and you're now free to go.
Thank you very much.
Thank you very much. So,
Thanks.
Off you go with the other.
Thank you.
Well, thank you very much, Ms. Grange. Now, that probably is all we have for today, is that right?
That's it. More smoke control witnesses tomorrow.
Well, we shall look forward to that.
Thank you.
Thank you very much. Well, then we'll rise at that point and resume at 10 o'clock tomorrow morning. Thank you very much.
Thank you.